All right, that's good. Okay, so basically, today we're going to be talking about concepts related to percents, ratios, linear models, and lines, as you guys probably saw in the discussion already. So first concept, we're going to be looking at percents. I'm just going to give a quick overview of what it is. The percent is basically like, it's similar to a proportion in that you're taking, for example, let's say I have 100 students, and I'm asking you guys, 50% of the students are taking the SAT. Now, to figure out how many number of students are actually taking the SAT, just take 100 students multiplied by 50%. A percent is represented in math as, if we write the symbol percent in math, it's basically mean 50 over 100 or 0.5. And so this is rewritten as 100 students multiplied by 0.5. And that should give us 50 students. So this is the amount of students that are taking the SAT. I mean, this is a very basic example. So doing problems are one of the best ways to solve this. So here I've got an example 1. Just zoom out a little bit. Okay, so the question is, Jacob got 50% of the questions correct on a 30 question test and 90% on a 50 question test. What percent of all questions did Jacob get correct? You guys can go ahead and start doing that right now. And we will go over the solution just in a bit. All right, so if you guys haven't yet looked at the solution, not really getting anything else. Okay, 75, all right. That's correct. So let's go ahead and see how Lasha got that answer. So basically, to find the total number of questions that Jacob got correct, we're gonna take 50%, because that's the amount of questions he got correct on a 30 question test. And we multiply that by 30, which is, again, similar to this. 50% is just 0.5 multiplied by 30, and that's equal to 15. So this is the amount of questions that he got correct on total. And on the other test, on a 50 question test, he got 90% of them correct. So we just take 90% multiplied by 50 questions, and that gives us, and again, if I were to rewrite this as a fraction, the same thing as 90 over 100 or 9 over 10 times 50. And this gives us 45 questions. So in total, Jacob got 15 plus 45, which is equal to 60 questions correct. So these are the amount of correct questions that he got correct. I'm gonna just move this real quick. So you got 60 questions correct out of the total of 90. And where I'm getting the 90 is he's got 60 questions correct, and out of 50 plus 30 questions, and that's equal to 80 questions. So in total, there were 80 questions, and out of that, 60 of them were correct. And so to do the final percent, we just take 60 divided by 80, and that's in reduced form 6 over 8 or 3/4, which is equal to 75%. So in total, he got 75% of the questions correct. Does that make sense? So another example, the spacing is whack on whatever I've done. I'm gonna have to move it every time. Sorry about it. All right, so for this question, the price of a dress is increased by 20%, and then decreased by 40%, then increased again by 25%. The final price is what percent of the original price? Again, I'm just gonna let you guys know that for this one, go ahead and use P as your original price. I'll give you guys a few minutes and then we'll go over the solutions. All right, Lasha, good job again. So basically how Lasha did this is they were initially saying that they increased the price by 20%. And if you guys aren't familiar with percent increases, basically if this is my original price and I've increased it by 20%, I multiply this by 0.2. That gives me the 20% of the amount that I'm adding on to the original amount, which is P. This is the total final amount that I have. Now, in math, there's something called a distributive property. So I can take out these P's and say this is 1 plus 0.2 or P times 1.2. And that's where they're getting 1 plus 0.2. So when I increase something by 0.2 or 20%, I'm just taking P times 0. 1.2, and that gives me my final price. So similar to that, here, when I initially increase the price by 20%, I'm taking P times 1.2. Or I'll write it like this. This might be a better way to understand. 1.2 times P. That's what I've initially done. And then I decrease this amount. So I increase this amount by 40%. So I'm taking, if I've decreased it by 40%, I now contain 60% of the amount. So I'm taking this entire quantity and I'm multiplying. So it increased by this much. And then I'm taking whatever it increased by and I'm reducing 40%, which is in turn 60%. If you guys are confused with it, you just take 1 minus whatever I'm decreasing by, which is 0.4, and I get 0.6. And then after I've gotten this, then I'm going to take this entire amount, and then I'm going to multiply that by 25%. And again, similar to the first time, we're going to multiply by 1.25 because we increased it. Now it means we hold the original 100%, and then we add a 25% to it. So we have 1.25. If we do plug it into our calculator, 0.6 times 1.2 times 1.25, you'll see that it comes down to 0.9 P, which means, what does that mean? That means the dress now costs 90% of its original price, or in other words, the price has been decreased by 10%. So does that make sense? All right, good. Another example, again, I'm gonna have to move this. Okay, this one is a savings account questions. Jonas has a savings account that earns 3% interest compounded annually. Her initial deposit was $1,000, which is the following expressions give the value of the account after 10 years. So I'll give you guys some time to do this before I talk about what a compound interest is and give the answer. All right, so we've got two different answers. One is D from Lashan, the other one is A from Ria, I think. Okay, so let's see how to do this. Compound interest is defined like this. You're taking the final amount, whatever you have after doing your compound interest, is equal to the principal amount that you have multiplied by 1 plus the interest rate to the power of t. Now, what does this really mean? So let's say that I have $1,000, and similar to this case, we have $1,000, and we're increasing by 3% each year. So if this is the amount that I have initially, and by the end of the year, I have 3% more, well, I multiply this by 1.03, right? It's as simple as that. And that gives me at the end of the first year. Now, when they say compounded interest, what they mean is the interest that I compound with is this price, which is kind of confusing, but I'll let you guys know what it is. What they do is they take the first price and then they multiply, they take the compound out of that, which is, so I take my first year's amount, which is this. I just literally rewrote this. This is the amount that I have. And I'm going to take 1.03 out of that. So by the end, whatever amount that I've compounded, I keep compounding whatever accumulated. So what this means is that I'm going to have like an exponential growth. And that's why the name is called compounding. So you just keep adding on to whatever you've got, and then you take that's interest. And this is the second year. And in the third year, it's similar to what you think. You take whatever amount was in the second year. So I take 1,000 times 1.03 times 1.03. So this is whatever, I just rewrote it. And then I take its interest, and then I add on to it. So it keeps going on. And if you see a pattern, the pattern is that, I need to rewrite that better. The pattern here is that for each year that I add on, it's 1,000 times the interest rate that I have, which is 1 plus r to the n. And in our case, r is 0.03, and this entire thing is just written as 1.03 to the power of n. And if it's the second year, we just plug in a 2 here because we've got 2 of these that are being multiplied. If it's a third year, It's 3 of these. So this is where the equation comes in. And so after 10 years, it's just simply saying 1,000 multiplied by 1 plus r. R in our case is 0.03, so 1.03 to the power of 10. And so the correct answer is D. So this is the correct answer for this one. This is the correct answer. And that's the correct answer. Okay, so hopefully that makes sense. Does that kind of make sense? All right, good. So let's go ahead and go to the next question. Okay, so here is another question, and this is about increasing and decreasing percents, similar to what we looked at before. So for this question, the number of students at a school decreased by 20% from 2010 to 2011. If the number of students enrolled in 2011 was K, which of the following expresses the number of students enrolled in 2010 in terms of K? So I'll give you guys some time to write this and find the answer. All right. So we've got one answer. Okay. So we've got 2 different answers now, C and B. All right, that's good. So we'll go over how to figure out the answer to this one. Now, you have to read the question properly in this case. So they're saying the number of students at a school decreased by 20% from 2010 to 2011. And here's why it's not B. The percent change is based off of the original value, which is 2010, and not the new value. So in 2010, the value decreased by 20%. Oh, sorry about that. So what's happening here is that in math expressions, 0.8x equals K. So the problem with this question is that they've given you the number of students that are enrolled in K. So that's where it kind of gets tricky, because what they're saying is from 2010 to 2011, only 80% of the students remained here, right? Which means, and that 80% that are remaining here, they call that K. So how do I revert back to this? Well, I'm going to say whatever 80% of my 2010's number of students, which we'll just call X, it doesn't really matter. And then 0.8 times X gives us a 2010's amount. So this is 2010's amount, number of students in 2010, multiplied by 80%. And that 80% gives me whatever number of students I had enrolled in 2011. And so because of the wording, it might be kind of tricky, but once you've got this expression down, it's just a matter of dividing by 0.8 on both sides, and you will get 1 over 0.8K or 1.25K. And that's just the way it is. So it's going to be option C. I think someone got that question right. Yeah, Lasha got it right. All right. So does that make sense? All right, good. Always practice these on your own, because watching someone do it is not always the best way to learn. Always do problems on your own. Okay, but yeah. So let's go to example, the last example, I think, in percents. An investor decides to offer a business owner a $20,000 loan at a simple interest of 5% per year, which of the following function gives the total amount A in dollars the investor will receive when the loan is repaid after T years. So I'll just highlight this. Simple interest. This is not compound interest. So like we did here, this is compound interest. Here we're doing simple interest. So that's a key difference. I'll leave you guys some time to work on it. All right, so I think that's enough time. We'll go ahead and do this question right now. Okay, so someone just asked, what is simple interest? Okay, so basically what simple interest is remember how over here we said at the end of the first year, this is the amount that I will have, and then they will basically use this amount to take the compound of that. So they took that amount and then they multiplied that by 0.03 to get the second year's amount. Rather than doing this in simple interest, they only use the original first year's amount that you're getting to, and then they just continually add interest to it. So symbolically, this is what it is. The final amount you have is P times 1 plus RT. Basically, I invest $20,000, and let's say my compound interest in this case is 5%. So original at the end of the beginning of the first year, we take 0.05. That's just getting the amount they're going to add on each year. This will give me, let me get my calculator. So this is $1,000. So what this means is they're gonna continually add $1,000 to your account. So the first year you're gonna have $20,000. Like as soon as you deposit, this is the amount you're gonna have. But at the end of the year, you have $1,000 added to that. That's the end of the first year. This is first year. At the end of the second year, all they do is they take your first year's amount, which is 20,000, whatever you had before. This is whatever I had before, and they just add another $1,000 on top of that. So it's just continually adding $1,000 to your account. And you can probably see why compound interest is better, because this is going to be a linear model. As time grows on, each time for each year, you're only going to add about $1,000. Compared to this, you're continually growing exponentially. So that's the difference between these two models. So here, basically what we're doing is we're taking $20,000, the original amount. So the answer here is D, because we're taking $20,000 multiplied by, so this distributed is basically saying $20,000 plus $1,000 times T. So if I have 0 years, which is like right as soon as I deposit, I'm just gonna have $20,000. After the first year, I'm gonna have $21,000. After the second year, I'm gonna have $22,000 a year. So that's why this is D. Does that make sense? It's just like you're just constantly adding on top of it. There is no like compounding. That's basically the only difference. Okay. So we just finished percents. The next topic is ratios and proportions. This one is pretty good. Shown up a lot on the SAT. I'll just get it ready in 1 second. So let's use area of a triangle as an example. Okay, so area of a triangle is 1/2 base times height. Let's say it's just a regular right triangle. Let's say that we go ahead and multiply. What we do is we multiply the base times 2. So our base turns into twice its base, and our height gets double 2. What happens to our area? You guys can go ahead and put in the chat. Do you think it'll get cut in half? Do you think it'll get multiplied by 2? Do you think it'll increase by 4? Um, whatever you're thinking, you can go ahead and put it in the chat. Meanwhile, I'm gonna get this thing set up. Okay, so good stuff for you. 4 times. Okay, so I'll just walk through this just in case. Okay, so here it is. Area of base, area equals 1/2 base times height. So we literally plug in our number. So we know area is equal to 1/2 base times height. But rather than b, we're going to have 2b here, and we're going to have 2h here. So I'm going to rewrite this. So 1/2, 2 times 2 is a 4. So we're going to have 4 here times base times height. And here's what it kind of gets weird. What you need to do is you need to move this out of the entire expression. What this allows you to do is it kind of lets you see the bigger picture. This literally tells you I'm 4 timesing my area. So, and in other words, you can, because we already defined A as this, I can just replace 4A, which just means my area has been multiplied 4 times. Okay, so that's just a simple example. We'll actually look at a problem right now. The length of a rectangle is increased by 20%. The width is decreased by 20%, which of the following accurately describes the change in the area of the rectangle. So I'll give you guys some time to do that. All right, so let's go ahead and look at this one. This one also delves into whatever concept we discussed earlier about percent, so I think it's a good connector for all these concepts. Okay, so first thing, area of a rectangle is equal to length times width. Again, we're going to just rewrite this expression. We're going to say A sub new, or our new area. I'll actually call this old area or original area, which is length times width. Here, we're going to have new area, which is equal to length, which has been increased by 20%. And remember, if it's been increased by 20%, we do 1.2 times L. So that's just our L value. We just increase that. What about the width? The width's been decreased by 20%. So again, we take 1 minus 0.2, which is equal to 0.8, which just means that the width now holds 80% of its value. So 0.8 times width. And when we multiply 1.2 and 0.8, we get 0.96. So I'm just going to write it like 0.96 length width. Now, here is where you need to, again, look at the bigger picture. I need to replace the length and the width by this because we have defined it as area old. So 0.96 times area old. This just now explains that the older area multiplied by 0.96 equals a new area, which means that the new area now holds 96% of the old area's value. In other words, it now holds 4% less. So the correct answer here is C. If there's any questions, go ahead and send in the chat. Does that make sense? All right, that's good. So let's go to the next question. So this one is actually related to physics in a way, but you guys don't need to do that. If you just recognize the formula, that's kind of cool, but you don't need to. So the question is, the force of an attraction between two particles can be determined by the formula above, in which F is a force between them, R is the distance between them, and Q1 and Q2 are the charges of the two particles. If the distance between the two particles is doubled, the resulting force of the attraction is what fraction of the original force? All right, so let's go ahead and do this one. I'm already starting to see some answers. So basically, let's just rewrite the formula. We'll say that this is force old is equal to 9 q1 q2, and the only thing we're changing here is the radius. We've just doubled it. So I'm going to replace r with 2r squared. Remember, I'm not doing this. I'm not just doing 2r squared. That's wrong. We're replacing this entire quantity here with 2r, and so we get we have to write it like this, which now implies that oops, we wrote this in the wrong part. This is the old force, so this is supposed to be r squared. The new force, however, does have and this now equals 9 q1 q2 over 4 r squared, or in other words, 1/4 of f old. Now, again, go back to read the question, because sometimes they might word this weirdly where they're asking for what is the old force in terms of the new force. But here they're asking the resulting force of attraction, which is our F new, is what fraction of the original force. So it's 1/4 of the old force. So it is, it's B. So good job on getting that right. But if they ask something like what fraction of the new force is the old force, then you would say, I'm going to have to multiply my new force by 4 times to get to my old force. So make sure to always read the question, because sometimes they might try to trick you. They're not trying to trick you, but just be careful in what you're trying to do, and then you should get the right answer. Does that make sense? All right, that's good. Okay, so let's go to the next question. It seems that I don't have anything else for ratios. That's good. Okay, so the other bigger concept is going to be lines. So we'll just look at a quick concept overview of what lines is. It's commonly written in this form. It's y equals mx plus b. Oops, sorry. Keep getting, so I don't know what's happening, but okay, so the equation's written like this. Y equals mx plus b, where m is the slope of the line times the independent variable. I'm so sorry. I don't know what's happening. Okay, so it's m is the slope of the line. We'll just zoom out. I think that might fix it. M is the slope of the line. B is a y-intercept. So I've written the slope of the line as rise over run is equal to y2 minus y1 over x2 minus x1. Pretty sure you guys all know that. It's probably taught in middle school. So here is a line. You guys need to know that 2 different types of like variations where you could have a vertical line. So this is a vertical line. This is a horizontal line. And vertical lines are described as x equals 3, which means my x values is always the same, but my y is undefined. Like, and that's why the slope on this is actually undefined, because the change in x is nothing and the y just grows infinitely. So the slope on this is undefined. So we say the m for this is undefined. For the horizontal one, we write it as y equals 3, where the y is always constant, is independent of the x variables, always 3. Y is always 3. So we say for this one, again, rise over run. Rise is nothing. 0 over our run can be anything we choose. And in essence, m is equal to 0 for a horizontal line. So this is just basic stuff for horizontal and vertical lines. Let's go ahead and look at a problem. It says the line shown in the xy plane passes through the origin at the point A, B, where A is greater than B, which of the following could be the slope of the line. I'll give you guys some time. Okay, so we've got two different answers, B and A. All right, so let's go ahead and go through this. They told us that A is greater than B. So this is just symbolically understanding what slope means. Slope is equal to, make this a little thicker, is equal to rise over run. And so basically in this case, rise is from the origin. So we're going from this point. Let's say we're just going from the origin to that point. The x change here is a because that's the coordinate a. In other mathematically, it's just a minus 0. So we take a minus 0, and then the change in y is b minus 0, and hence the delta x is a, delta y is b. So rise over run, rise is b, run is a. And now they tell us that a is greater than b. What does that mean? That means my denominator is greater than the numerator. What does that mean? That means that our number has to be less than 1. So it can't be 1. 3/2, it's not possible. I can't take. Again, you can even look at the options. 3 over 2, how is 2 greater than 3? Right? Because this is our A. So what that leaves us with is that it can't be 1/2 because our slope, again, these are two positive numbers, so it can't be A. The only thing that's possible is B. This is less than 1, but it's also greater than 0, right? It can't be negative 1/2 because we have a positive change in X and a positive change in Y. So does that make sense? Okay, so let's go to the next question. If a line has a slope 1/3 and it passes through the point 1, -2, which the following points also lies on the plane, on the line. So for this question, make sure you use this equation, y equals mx plus b. Again, you have to solve for b. You have to solve for all these variables with the given values. I'll give you guys some time. All right, I think that's enough time. We'll go ahead and go through the problem. So they tell us that a slope is 1/3, which means we can just replace m with 1/3 x plus b equals y. And the next part is just figuring out what point also equals b. Actually, I didn't mention this, but you could also do the slope technique if you wanted, but we'll do this equation and I'll also show the slope technique, which might be easier actually. So y equals 1/3 x plus b. And to solve this, we just go ahead and plug in our values that we are given, which is 1 and -2. So plug in -2 for y equals 1/3 of 1, because that's the x, plus b. This tells us that -2 equals 1/3 plus b. And then when we subtract -2 minus 1/3, we get -7/3 is equal to b. So our equation now is just y equals 1/3 x minus 7/3. To figure out if any of these options work, we can just merely plug the 2's in, the -2's into this, and see if we get a -5, because this basically expresses all the possible values of y for a given x, and the equation should match up. So if you go ahead and plug in all the points, the only one that works is C, because if I plug in a 4, we get 4/3 minus 7/3, and that's equal to -1. So C is the only one that works. If you want, you can go through them. This is a much it's a much more tedious method to do, but it gets more concept across about what a line means, how all the points lie on it, and stuff. But for time's sake, SAT, it's probably not the best thing to do. So what you want to do is just read the slope. The slope is 1/3, which just means up 1 and right 3. So if I take this point, if I have 1, -2, if I move up in this, so I just add 1, just 2, and then I move right 3, I have -2 plus 3, which is just 1. So that's one of the points. Still, none of the points match up, and I think if we go right once more, I just went ahead and I added. So we just added 1 here, and we added 3 here. That's all we did. And then we're going to do it again, because it doesn't matter, right? The slope always has the same slope. This line always has the same slope. So if I add 1 here, we get 3, 4. And if we go ahead and 1 second, the point 4 equals -1. Okay, I'm not sure what mistake I'm doing right now. But okay, so if we go to the right, the point we get to the line is 4, -1. Because okay, yeah, I got the wrong slope for the -2/3. So this was wrong here. But basically, you can use the slope technique to also get the correct answer. All right. So we'll go to this example. A line L passes through the points -2, 3, and 3, 13. What is a y-intercept of line L? This one probably is much better to do it this way, because I don't know how you would do it with the slopes. You could always keep moving up and down and see where it hits 0, some y, but the equation method might be easier for this. All right, so we'll go ahead and go over this question real quick. So the line passes through -2, 3, and 3, 13. The first thing that I want to do is just write down the formula, mx plus b. What is m? M is equal to change in y. The delta just means change in y, or yf minus yi, like whatever initial value I had minus y. So let's rewrite it like y2 minus y1 over x2 minus x1. And this equals, well, let's just let's use this as the second coordinate, first coordinate. So we do 13 minus 3. And then for our x2, that's going to be 3 minus x1 is going to be -2 minus -2. Remember, see that I made a parentheses here so that I don't get the things mixed up. I'm merely replacing the x. I'm making sure that negatives stay consistent, because what happens here is that these negatives turn into a plus. So this then turns into 13 minus 3 is 10. 3 plus 2 is 5, and then this equals 2. So the slope is 2. We got that figured out. So next thing is just rewriting this as y equals 2x plus b. And then we can just plug in any of these points. Let's just pick 13 and 3. So I'm going to plug in 13 into y. 13 equals 2 times 3 plus b. This is 6. 13 minus this is equal to 6 plus b. And then I subtract 6 from both sides. We get that b is equal to 7. Okay, so again, finally rewriting the equation just if you wanted to, but this is the answer. You can just write this, but the equation would look like this: 2x plus 7. And this is the y-intercept. All right, does that make sense? If you guys do want me to go over this slope thing again, I can always do that. Because I didn't really go over that, kind of skimmed over that. Yeah, Lasha, it's 313. That's the coordinate point. What do you mean by 313? Like exactly where? Okay. All right, that's fine. All right. So if that's good, if that makes sense, I can move on. Just send a yes in the chat if that makes sense so that I can move on. Okay. So that's good. All right. Let's go ahead and move on. So next thing we're going to be looking at is parallel and perpendicular lines. The question that we're going to deal with requires us to know the concepts of perpendicular and parallel lines. So I'm just going to quickly go over it. Parallel lines. So if I define the slope of this line as m equals, let's just say a, then the slope of this is also equal to a. What that means is they're always going to be constantly growing at the same rate, which means they're going to be parallel or they're never going to intersect. The only way that parallel lines are going to intersect is if they're literally on top of each other. So if I have this graph and two lines are on top of each other and they have the same slope, then they will intersect, and they're intersecting infinitely. They're just on top of each other, they're constantly intersecting. But if they have different slopes, right, then they will never intersect. That's just because they're parallel. Perpendicular lines have, let's say that I define one of these lines slope as m equals a. The other one's slope would be 1 over negative a. That's just how the slopes are kind of defined. So if you take the inverse, which is the reciprocal of m, and then you multiply that by negative, then you get a perpendicular line slope. What do they mean by perpendicular? The angle between them is 90 degrees. So if that makes sense, we will go ahead and go to the actual problem. Line M has a slope of 2/3 and passes through the point 4,3. If line N is perpendicular to the line M and passes through the same point 4,3, which of the following could be the equation of line N? I'll give you guys some time. All right, so I'll go ahead and go over this. I probably didn't label this properly, but if I were to rewrite this in better subscripts, if I wrote this as, this is M, that's the slope of this one, then the slope of this line is also going to be M. Similarly here, I'll just rewrite this all in terms of M. I think that would be better. This is M. The slope on this line is going to be 1 over negative M. I think that's a little easier to see than using A's. So, yeah. So here's a question. Line M has a slope 2/3 and passes through the point 4,3. Now, what you have to do is just first figure out what the perpendicular line's slope will be. So if the slope of the first line is 2/3, right in white. So if the slope of the first line is 2/3, then the other one would be the reciprocal of it, which is 3/2. Then we just multiply by -1. So this is the perpendicular line slope. Okay. Now, which of these match? Well, it can't be A. That's not possible. The slopes don't even match. So you can just cross that off. What about B? -3/2. Okay. C, -3/2. D. Okay. So we were only able to cancel off letter A. So let's see what steps I need to take. Now I have to figure out if the y-intercepts are correct. So these values, we have to figure out which one's the correct one, and we'll be good to go. Here's a clue, right? They've told us what points they both pass through. They both pass through 4, 3. So what that means is, right, our equation is going to be equal to y equals mx plus b. Again, this is the equation of line n. So y equals -3/2 x plus b. And because they have the same point that is passing through, we can just plug in this point, 4, 3. Okay, so plug in 4. X is 3 plus b. And then when I solve this out, I get 4 equals -9/2 plus b. And b equals, oops, sorry, 1 second, I made a mistake. What we get is, I don't know if I showed this to you guys yet, but there's also another form for this, for slope intercept. You could either do slope intercept or the other way, which is y minus y2 equals okay, so this is another form which you can use. I think personally, you would use this a lot in calculus to easily get your tangent line formulas. But if we use this here too, because it's personally easier, I just go ahead and plug in whatever point that I have. This is called point slope form. This is slope intercept form. So we can just plug in our values of -3 and m, again, is -3/2, x minus 4. Okay. And then when I distribute these -3/2 to both sides, we get -3/2 x plus 6 plus 3. I'm just going to add the 3 over, and then equals -3/2 x plus 9. So then this value is equal to the option D, because that's this one. Again, you could have used this or you could have used this. It doesn't really matter which one you choose to use. I just, again, stopped in the middle and decided to use this only because it was just easy. I didn't want to deal with fractions, and this just seemed easier. So does that make sense? All right. So lines is over. The next concept is linear model. This is the last one we're going to be looking at. So there's only a few questions for this, and then we'll be done. Okay, so interpreting linear models. These are seen a lot on the SAT. There's not really concepts you have to learn. It's more about just understanding what it means. So here's one. We'll just do maybe the part 1 or part 2. We can probably do both these parts, but we'll see. So the value V in dollars of a home from 2006 to 2015 can be estimated by the equation V equals 240K minus 5,000 T, where T is the number of years since 2006. So go ahead and try to do part 1. Okay, good. So here's the first part. It's asking you which of the following describes the meaning of the number 240K in the equation. If you guys want to write this in y-intercept form, probably the easiest one to recognize what it means, you just have to take y equals mx plus b, and y here is v, which is the value of the home, equals m, and our M is negative 5,000 T plus 240K. And as you can see, this is the value of the home, and as described in part for letter A or choice A. So good job on getting it correct. I'll give you guys some time for part 2. All right, so for part B, it's asking which of the following describes the meaning of the number 5,000 in the equation. So this is the value of the home, which basically means always designates the rate or the increase or decrease in Y, or the value of the change in the value of the house. So which means the value of the home decreases by 5,000 each year. So it's B. A doesn't work because it's saying the number of homes sold each year. That's not what it describes. We're talking about dollars, the value that it decreases by. So it's not A. C is the difference between the value of the home in 2006 and 2015. What? I don't understand that. D, the yearly decrease in the value of the home per square feet. I don't know. We're not taking per square feet. Nothing even talks about per square feet, so it can't be D. So let's go to the next question. The maximum height of a plant H in inches can be determined by the equation H equals 4x plus 6 over 5, where X is the amount of fertilizer in grams used to grow the plant. According to the equation, 1 gram of fertilizer would increase the maximum height of a plant by how many inches? I'll give you guys some time on this one. All right, so basically this question's asking us, it's like interpreting the slope. So basically, if I were to rewrite this fraction 4x plus 6 over 5 as like a split up fraction, right? This will let us know much better what it means, because now we're in the world of y equals mx plus b, which now means the maximum height h a plant is grown is determined by x, which is the amount of fertilizer. So all that means is, what would 1 gram of fertilizer amount to, right? If we rewrite this equation in terms of x, you would get that I'm going to go ahead and multiply both sides by 5. We're going to get 5h plus 4x plus 6. X is then equal to, I'm just going to subtract, add on the same line, 5/4 h minus 3/2. This means that for each 1 increase in x, or each time I add 1 here, my amount of height increases by 5/4. Sorry, I was doing the second part. My bad. Very sorry about that. This is merely just looking at 4/5 and saying 0.8. I was reading ahead. Sorry, I was looking at the wrong problem. But yeah, this just means this is the increase in height of maximum height. This is the amount of fertilizer we have. So if we just take then 5 divided by 4, we get 0.8 increase in height over 1 unit of fertilizer added. And so it's 0.8. So good job of getting it correct. And okay, so yeah, this is the problem. I already did some of it because I was reading the wrong question. To raise a maximum height of a plant exactly by 1 inch, how many more grams of a fertilizer should be used in growing the plant? So here's the second question. that I abruptly started earlier. Okay, so here's what I started earlier. They are telling us that the height increases exactly by 1 inch, which means we're basically solving for x, which means they're asking us how many more grams of fertilizer should I add on so that I get one added increases in height, or one added inch. So 1 equals 4 times x, which we're solving 4 plus 6 over 5. I'll multiply by 5 on both sides. 5 equals 4x plus 6. Okay, so we multiply by 5. 5h equals 4x plus 6. I don't know why. I just forgot about the h, but 5h equals 4x plus 6. And then we subtract. Minus 6 equals 4x. We divide by 4 on both sides. Now x equals 5/4 h minus 3/2. Now you can easily just plug in the h as 1, and then the x should come out to equal 1.25. The other way that I personally like better is the slope way. We previously figured out that 4/5 is the slope, or 4/5 inches is increased if we add 5 grams of fertilizer. That's what this means, because this is change in y over change in x. That's what this means. So if I add 5 grams of fertilizer, my plant's maximum height will increase by 4 inches. So now that we know that, we just have to make this equation in a way where we get 1 inch on the top. So if I divide by 4, we get 1 inch over 5 divided by 4 is 1.25. And that's 0.8. So we just get that to get 1 added inch of maximum height, we have to add 1.25 grams of fertilizer. So that's the answer. This is a much easier way to look at it than this, but either way works. Here's the last final question. Go ahead and work on it. All right. A can of soda is put into a freezer. The temperature T of the soda in degrees Fahrenheit can be found by using the equation above, where M is the number of minutes the can has been in the freezer. What is a decrease in the temperature of the soda in degrees Fahrenheit for every 5 minutes the can is left in the freezer? Okay. The slope, again, if you want, you can rewrite this equation as y equals mx plus b. I'm just going to rewrite t is equal to, so I'm just replacing the y's and the x's with negative 6x plus 65. In this case, the temperature, and if we just analyze the slope by itself, negative 6 over 1, or the temperature decreases by 6 degrees Fahrenheit. So this is temperature for every 1 minute added. So for each minute that we add, we decrease by this much. So again, for 5 minutes, we just multiply both the numerator and the denominator by 5. That gives us negative 30 over 5. What that means is 5 minutes in the refrigerator or the freezer, the can's temperature will go down by 30. So what is a decrease? Well, 30 is a decrease. So good job on getting that right. So if we just have to pan out, this is all the work we did. So we started on percents. And then we went into ratios. Oh my God, a lot of work. And then we moved on to lines. So we started on percents to ratios to lines to interpreting models. So a lot of major concepts that you will look at on the SAT. So yeah, that's it. If you have any more questions, go ahead and put it in the chat. And that's basically it for today's event. Thanks for joining.